Grader, blade, patrol, motor grader. This machine has several names, and it's used on most highway maintenance and construction jobs, windrowing, spreading, and mixing material. From rough cuts and snow plowing to delicate finish work, the motor grader is one versatile piece of equipment, and it takes a great deal of skill to operate. This program covers motor grader operation from the operator's point of view and is divided into two parts. Part 1 covers some basic information about the motor grader, as well as the startup and shutdown procedures. Part 2 covers blade positions and maneuvering. Okay, let's get started with some basic information. A motor grader is designed primarily to level or smooth an area. To do this, it has a long wheelbase so it can span short depressions or bumps. The mold board is carried in the center, so bumps can be cut off and depressions can be filled in. The tandem axle in the back helps too. The axles move independently, so there's little up and down effect on the frame of the machine. All graders have this basic design in common: the long wheelbase, the center mold board, and the tandem wheels. But there are about as many different models of graders as there are heavy equipment manufacturers. There are differences from one model to the next. All graders have rear differentials that provide positive traction. That's where the tandem axles are locked and the wheels on both sides of the grader turn together. But some graders have differentials that can be unlocked to make turning easier. When the differentials are unlocked, the wheels on each side of the grader turn independently of the wheels on the other side. Finally, most graders are articulated. On these graders, the frame pivots on a joint behind the cab. Articulation allows for sharp turns and easier positioning of the grader at the work site. A few graders are non-articulating. They have a rigid frame. Each motor grader has its own system of instruments and controls. It may have 4-wheel or 6-wheel drive. It may have a lock-unlock differential. And the grader may be articulating or non-articulating. Because we can't cover all the models in this program, be sure to read the operator's manual. Get to know the location and functions of all the instruments and controls. Learn the capabilities and the limitations of the machine you'll be using. Now, the startup procedures. As an experienced operator, you know that startup involves much more than turning a key. You have to complete a series of daily checks to be sure the grader is in good shape. In this program, we'll divide the daily checks into 4 parts: the walk-around inspection, engine checks, lubrication, and the cab inspection. We will go over them separately, but you can combine the engine checks, lubrication, and cab inspection into your walk-around. Whatever works the best for you to get the job done efficiently. Let's start with the walk-around. It's a general, overall look at the machine. The purpose of the walk-around inspection is to spot obvious problems, leaks, damage, and loose or broken parts. If you find anything wrong, fix it yourself or let your supervisor know. Leaks of oil, coolant, or fuel are certain signs that something is wrong. Investigate and get the problem corrected before you go on. Pay special attention to the rear tandem wheels. Note any wheel lean. That might mean you've got a bad axle bearing. Keep an eye out for deep cuts and excessive and uneven tread wear. Look for loose or broken lug nuts. Make sure everything is tight. Take a look at the mold board and the blade that's attached to the mold board. Blades do wear out, and when they do, they have to be replaced. A worn or cracked blade could damage a mold board. Look for leaks or loose fittings around the hydraulic lines. Hydraulic leaks can be dangerous because the oil is under high pressure, so keep all fittings tight. And that's it for the walk-around. It's a general look at the equipment, taking care of problems that could affect your safety or the operation of the machine. Now, engine checks. For the engine to run, it needs oil, coolant, air, and fuel. Those are your main points to check. First, oil. Check the engine oil every day. You never know when an engine is going to start burning oil. And note the condition of the oil. Contaminated oil can ruin the engine. Oil that is discolored, feels gritty, or smells of fuel is a sure sign of a major problem. Now, air. Dirty air is one of the leading causes of diesel engine failure. That makes air filters absolutely critical. Most graders have an air filter restriction indicator. If it's been tripped, it's time to check with your mechanic. They can decide if it's time to clean, or more likely, replace the air filter. Next, coolant. Most all the new graders have a sight gauge. Make sure it's at the level it's supposed to be at. On older graders, you will need to remove the radiator cap and look inside. The coolant level should cover the entire radiator core. Keep both sides of the radiator grill clear. If the grill gets clogged, the engine could overheat. Bad fan belts and hoses can cause overheating too. If they are loose, tighten them. If they're worn or cracked, get them replaced. A loose fan might mean the water pump is broken. There shouldn't be any play at all. The fuel you burn has to be cleaned too. Water and sediment in the fuel causes all kinds of problems. Problems that lead to breakdowns. One more fluid level to check. The transmission oil. How and when you check the transmission oil will vary from one model to the next. On this grader, you simply pull the dipstick. In any case, if you have to add fluid, be sure to add the right type. Now let's take a look at lubrication. Quite a few of DOT's graders are equipped with auto greasers. On your walk around, make sure it has a sufficient amount of grease and make sure it is working properly. Another thing to remember is that even if the grader you're going to run has an auto greaser, they do not grease every fitting on the grader. So check and see if all the fittings are getting greased, either by the auto greaser or by yourself. There will be a lubrication chart in the operator's manual or in the grader itself. The chart shows the location of the grease fittings and the recommended service intervals. As part of daily maintenance, you should focus on greasing the parts that get the most wear. On graders, that includes the moldboard lifts and linkage. Look all over for fittings that look dry. Grease is cheap compared to repair charges. Now, the front end. Grease all steering parts. And notice how he wipes the fitting clean before he adds more fitting grease. That prevents forcing dirty grease into the fitting. There are plenty more points to grease. Again, refer to the operator's manual to find where they are and how often they should be serviced. You still have a few more checks to make, but they should be done after you start the grader. Before you start up, make sure the transmission is in neutral and the parking brake is set. Don't crank the starter for more than 30 seconds. That'll wear it out. If the engine doesn't start right away, wait a minute or so before you try again. A few more points about starting. Never attempt to start the grader unless you are sitting in the operator's seat. It could get away from you. And if you're inside a garage or shed, make sure there's plenty of ventilation. Exhaust gases are poisonous. Before you get started, run the engine at idle speed for 5 minutes or so. It's important. The engine needs to warm up so an oil film can develop on the cylinder walls and other internal engine parts. And it gives you time to complete the cab inspection. Check your gauges and keep them clean so they can be seen clearly. And make sure all the gauges are working. They can tell you a lot about the condition of the grader before you leave the yard. Take some time to clean up the cab. Wipe off greasy floorboards and remove any trash that could interfere with the operation of the controls. Make sure you can see clearly through the windshield, side glass, back glass, and mirrors. And check the windshield wiper. If the blade is worn, get a new one. A streaky windshield is dangerous. Check the seat. A properly adjusted seat adds to your comfort and safety. Make sure your lights are working. You'll often work in isolated areas and your lights may be the only traffic control you have. And take a look at the exhaust smoke. Thick, black, or white smoke indicates engine trouble. It should be almost colorless. You are almost ready to go, but before you get moving too fast, test your brakes. Make sure you have a full pedal, that it doesn't go to the floor. Put the transmission in reverse and test the backup alarm. There's one last thing to do once the walk-around is completed. You need a sign-off on the daily check sheet that's in the grader. It helps make sure you haven't missed any safety checks during your walk-around, and it will keep a record of you as a responsible operator doing your part to keep the equipment in good working order. And that's it for startup. But the daily checks don't end when you pull out of the yard. In fact, they continue throughout the day. Look, listen, and feel for signs of trouble while you're working. Pay attention to the gauges. If anything goes out of the normal operating range, stop working and investigate. Let's cover shutting down. What to do at the end of each day. First, fill the fuel tank. Filling it at the end of the day helps condensation from forming in the tank overnight. If it's at all possible, park the grader on level ground. If you have to park on a slope, block the wheels. In any case, put the transmission in neutral and set the parking brake. Lower the blade and any other attachments to the ground. Don't shut off a hot engine unless it's an emergency. Let it idle for 5 minutes or so to let it cool down gradually. And after you shut down, walk around the grader one more time. Look for any damage that occurred during the day. Finding problems at shutdown will put you that much ahead in the morning. That concludes part 1 of motor grader operations. The grader is a complicated machine and it requires a lot of skill to operate it correctly. Try to think of the daily checks as a part of that operation. Now in part 2, we'll look at positioning the blade for different kinds of work and maneuvering the grader. Let's start with blade positions. As I said in part 1, the grader is a versatile machine. It has to be. It's used in a wide variety of maintenance tasks. From grading roads to plowing snow. From cleaning ditches to blading asphalt. The list goes on. The critical factor in all these operations is blade position. You can choose from an infinite number of blade angles and heights to meet the demand of any grader operation. But there's more to it than just knowing what blade settings should work. You have to develop a feel for the grader and its controls. Successful operation of a motor grader depends on the instincts and split-second reactions of the operator. While those instincts and reactions are developed through experience, we can show a few of the possible blade settings and explain how they are used on some common maintenance activities. There are 5 blade movements: blade lift, circle rotation, blade pitch, blade side shift, and circle side shift. All grader operations require a combination of some or all of these basic movements. The hydraulic controls in the cab of the grader direct each of these movements. But as you'd expect, the controls vary from one model of motor grader to the next. So we'll concentrate on the movements, not the controls. The first movement is blade lift. You can raise and lift the entire mold board or just one end at a time. For example, if you wanted to level an area, you'd probably set both ends of the blade at the same height. On the other hand, you'd probably set one end slightly higher than the other end if you wanted the surface to have a crown or slope. When you lower the blade until it barely touches the surface, you have a loose blade. That's one of the 2 basic operating heights. The other is a tight blade. That's when you put enough downward pressure on the blade to dig down into the surface. A loose blade works best when the job calls for spreading or mixing loose material. As you can see here, the blade picks up only the loose material on the surface without damaging the pavement underneath. A tight blade is used when you need to reshape the surface by cutting into it. However, most jobs need the combination of a loose and tight blade. Generally, you'd set the toe or leading end of the blade tighter than the heel or trailing end. This works well when you're cutting or windrowing material. The second blade movement is circle rotation. The blade is attached to a circular mechanism mounted on the grater's frame. By rotating the circle clockwise or counterclockwise, you can achieve any blade angle through a range of 360 degrees. When the blade is straight across the frame, it's at the 0 degree or spreading angle. All other blade angles are measured from this position. As the name suggests, the spreading angle is used for spreading material. The blade pushes the material forward with a dozing action. The material spreads to both ends of the blade, leaving little or no windrow on either side. Now, as you rotate the circle, you change the blade angle. Most jobs require a blade angle between 15 and 45 degrees. When you increase the blade angle, you increase its ability to windrow rather than spread material. The general rule is to use a sharper blade angle to make a larger windrow. The blade angle also affects the placement of the windrow. In most cases, you'll want to set the angle to place the windrow either outside or inside of the rear wheels. What you don't want is to have the rear wheels riding on the windrow. That reduces traction, and the up and down movement of the grater will make your cuts uneven. One more point about circle rotation. A change in blade angle often results in a change in blade height. As you rotate the circle, one end of the blade goes down and the other end rises. So as you change the blade angle, you may also have to change the blade height to get the position you need for the job. Now, the third movement, blade pitch. Blade pitch is the vertical angle of the mold board. You can pitch the blade forward, backward, or leave it in the upright position. A forward pitch gives the blade a dragging action, and a backward pitch gives it a cutting action. For example, this operator has his blade pitched slightly forward. By applying only slight downward pressure on the blade, he can drag and smooth the surface without cutting into it. The forward pitch also provides compaction. It kind of squeezes the material together for better mixing. So for dragging or smoothing the surface or compacting material, use a forward pitch. But for cutting or reshaping the surface, use a backward pitch. In this position, the cutting edge of the blade is up front. By applying downward pressure on the blade, you can dig into the surface instead of just dragging it. You lose the compacting action you have with a forward pitch. Okay, that's blade pitch. Now blade side shift. The fifth and final movement is circle side shift. Circle side shift accomplishes the same thing as blade side shift. It extends the reach of the grater. The difference is that in blade side shift only the blade moves, but in circle side shift you can move the entire circle from one side of the grater to the other. That not only extends the reach of the grater, but also makes it easier to position the blade for certain types of work. Here's a quick review of the 5 movements: blade lift, circle rotation, blade pitch, blade side shift, and circle side shift. All motor grater operations involve a combination of these 5 basic movements. But it's impossible to assign a specific blade setting for any particular job. What we've shown here are guidelines. You'll have to experiment with different blade positions on the job to see which setting works best. Now, let's look at maneuvering the grater. Before you leave the yard, you'll have to position the blade for travel. Here's how it's done. Lift the mold board and rotate the circle until the heel of the blade is in front of the left tandem tire. The toe of the blade tucks in next to the right front tire. Not too close, though. You don't want the blade to hit the tire when you turn. Try to keep the mold board within the width of the grater. However, if the mold board is too long, extend it out to the right side so it won't interfere with traffic. For the most part, driving the grader on the road is about the same as driving any piece of equipment. The same rules apply. Always travel at a speed that's consistent with the road, the traffic, and the weather conditions. Upshift and downshift the transmission one gear at a time. And stay in gear, never coast in neutral. Slow down well in advance of intersections and turns. The grader is a heavy machine, and once it gets rolling, it needs plenty of time and distance to slow down and stop. Graders have a couple of moves that you might not be familiar with. The first is front wheel lean. There's a control in the cab that lets you lean the front wheels to the right or to the left. You can use front wheel lean to get the grader through sharp turns. Articulation or frame steering provides additional help in turning. By articulating the frame, you can cut down on the amount of room you need to turn. The thing to remember here is always check the position of the blade before you articulate the grader. If the blade comes into contact with the rear wheels, it will damage them. You'll use wheel lean and frame steering to maneuver the grader on the job as well as on the road. For example, when you're windrowing material, the weight of the material pushing against the toe of the blade pulls the grader in that direction. You can counteract that pulling force by leaning the front wheel in the direction you're moving the material. That helps you keep the grader going in a straight line. And when you're pulling a ditch or working on a slope, use frame steering. It lets you keep the rear wheels on stable ground while the front wheels ride on less stable or uneven ground. That lessens the up and down movement of the blade caused by the variations of the surface, and you get a better cut. As I said before, exactly how to position the grader and set the blade is determined by many factors. But for most types of work, the normal operating position of the grader should be like this. The frame of the machine in a nearly straight position so that the front and back wheels follow almost the same path. The front wheels straight up and down or with a slight lean to the way you are moving the material. Blade lift cylinders straight up and down so the mold board table is squarely under the grader, and the blade pitched slightly forward and angled between 15 and 45 degrees to cut and windrow material. That concludes Part 2. We've covered some blade positions and basic maneuvering. In Part 1, we covered the daily checks and how to take care of equipment. These skills build the foundation for becoming an expert operator. Once you start running a grader, you'll start to learn the infinite adjustments, positions, and jobs a grader can do.